the limit as x approaches 0 of sine x over x. What do we have to do here? Make our tables. It is approaching 0 from both sides, so we need two separate tables. So yesterday we just did the x and y. We don't have to have the slope here because I'm not trying to estimate the tangent line. So approaching 0. What would I do for my numbers smaller than 0? For whatever reason, that's where people always make a mistake. They want to put like negative 0.9 for some reason. So just be aware of that. And then approaching 0 from the other side would be positive. Okay, we're not going to take forever for me to plug all these in. You guys are going to do that. We're going to just divvy it up. Make sure your calculator is in what mode? Radian mode. So U2 do negative 0.1, U2 negative 0.01, U2 negative 0.001, Logan and Maddie do 0.1, U2 do 0.01, Alex and I will do 0.001. Negative 0.1, what did you get?
8.3, actually.
No problem. Okay, negative 0.01. Okay, negative 0.001.
0.9999998.
I don't even know how many nines
There's
there's.
like 6 nines.
Okay. 0.1. What'd you get?
0.999.
0.01. 0.001. Okay, so can we tell what this is approaching? Yeah, it looks like from both sides it is approaching 1. So we can estimate the value of that limit. Now, is this method foolproof? Is it guaranteed that we're exactly right? No, but we're pretty confident in that. All right, limit as x approaches 0 of sine pi over x. So we are approaching 0, so my table looks the same for my x's. I want you to do the same one you did last time. My negative 0.1 people. Negative 0.01. Next group.
0.
Okay, next group. Next group.
0.
Next group.
0.
All right, so what would we say this looks like? 0. Why don't you graph this real quick? So go to your y equals and plug in sine pi over x. You might need to hit zoom and go number 7 for zoom trig. Okay, so you get a graph that looks something like this, right? My awful sketch. Okay, if you zoom in a little bit, so hit zoom in and just go right there at 0, 0. What's going on? Kind of went crazy, didn't it? You just have all these back and forths. Actually, if you zoom in, all this is doing is constantly oscillating back and forth between -1 and 1. The limit at 0 does not even exist because it's oscillating so frequently there. It's just jumping back and forth. So this one really just illustrates how sometimes this method can be misleading. Okay, if we had plugged in some different points, we might have gotten some different answers. So this one does not exist. Now, no way that you would know that just by looking at the tables that we got, but I just wanted to show you how it can be misleading sometimes. Okay, number 3. We skipped that one yesterday too, right? Okay, I want to look at the limit as x approaches 0 of this. So we could do it by a table. Let's just graph it. I think you guys need some practice graphing piecewise functions, don't we? Seem a little rusty on those. Okay, so when we graph piecewise functions, we do essentially like one t-chart for each piece. I'm telling you, the function itself was x divided by the absolute value of x, but it turns out to be 1 if x is greater than 0, -1 if x is less than 0. So we can graph that pretty easy. If x is greater than 0, so starting at 0, it would be an open circle, you're just getting out 1. So for every positive x, this is giving me a positive 1. For every negative x, what are we getting? If x is less than 0, it gives us -1. Now you could make a t-chart if you needed to. These are just 2 horizontal lines, which is why I just skipped to graphing them. Okay, so can you look at this? As you approach 0, as I come in for from both sides, what would you say? Doesn't exist because those two don't match up. For the limit to exist, they have to go to the same value. So D and E does not exist. Okay, I talked about examples 5 and 6, and we also went through what an infinite limit is yesterday, so we're ready for example 7, I believe. Okay. So if I look at this one, you want to look at a graph? A square root of x, that's not too hard to graph, is it? So you can use your calculator if you need to, or you can just plug in points. Can you do the square root of negative numbers? No, so if you start with 0, square root of 0 is 0. We put in a 1, square root of 1 is 1. And we could do 4, 2. So we're getting something like this. So the limit as x approaches 0, what does that plus sign mean? From the right. So we are coming in towards 0 from the right hand side. What is my y going to? 0. The limit as x approaches 0 from the left. If I'm approaching 0 from the negative side, do I even have a graph over here? So can I even approach from the negative side? So what's that limit? Does not exist. one all right? Let's get another. Okay, so again, we could do it from a graph. On a test, if you don't have a graphing calculator, this is probably not a graph that you can as easily just sketch on your own, right? So let's talk about the table. Now, obviously on a test, I'm probably not going to be able to ask you to do the full table without a calculator either. I will give you a little more of that information, and we're going to learn some better options for doing these. So right now we have to rely on our calculator, but the types of questions I would ask on a test would not. So if I wanted to do this, if I'm doing the first one, just to do this first limit, do I require 2 tables? No. That's only saying the limit as you approach 3 from the right, so numbers bigger than 3. So all I would have to do there would be my 3.1, 3.01, 3.001. Okay, if I plug those in, what's this going to? What's happening to these numbers? They're getting bigger. So what do you think this is going to? Infinity. So my right hand limit here is infinity. Let's do the left hand. So we need numbers smaller than 3. Like 2.9, 2.99, 2.999. And I'm getting negative 58, negative 598. I think I can guess what the next one is, but I should probably check. Negative 5998. What's this one going to? Negative infinity. So from the right it went to positive, from the left it went to negative. So if I said overall, if the question was what's the limit as x approaches 3 of this, what would that be? Does not exist. What's happening at 3 is we have a vertical asymptote. As we're coming in from the positive side, it's going to infinity. As you're coming in from the negative side, it's going to negative infinity. So they don't match, but if you did left and right separately, you do have limits. Is that one okay? We're going to do just a couple more, and then I'm probably going to stop for today. So number 7. Do you guys want to try this one on your own? It's only one-sided, so you just have to plug in a few numbers. So give it a try. So you're only approaching from the right, so we only need the one table. And if you put in 0.1, you get 4.0949. So what is this approaching? 4. All right, last problem for today. I'm actually not going to do example 8. We're going to skip it. But I might do a different one. So this may not be the last one, second to last. How about that? If I'm looking at this one, limit as x approaches 3 from the right of 9 minus x squared. If you make your table, we try our 3.1, 3.01, 3.001 because it's from the right, number's bigger than 3. Start plugging those in. What do you get? Error. Okay, let's think about the graph here. You can graph it on your calculator, or we could just plug in some points. If I put in a 0, I get the square root of 9, which is 3. So 0, 3. If I put in a 1, I get the square root of 8. If I put in a 2, I get the square root of 5. If I put in a 3, I get the square root of 0, which is 0. Okay, if I put in negative 1, I get radical 8. Negative 2 gives me radical 5. Negative 3 gives me a 0. And then can you put in anything beyond that? If I put in a positive 4 or a negative 4, then it's undefined. What this is a little semicircle. So we can see from that graph as well, we got errors over here. As you're coming in from the right, does the graph even exist? So that one does not exist. Instead of example 8, I want to do a problem like one on your homework. So if you would please open your book to page 97. And I want to do problem 16 together. I think I assigned 15 on your homework. So this tells us to draw a graph that meets all of these conditions. Now I'm going to tell you right now, you're going to have one on your homework. I will probably put one like this on a test and a quiz. You are not just going to be able to read through that list of conditions and look at your graph and draw a perfect graph. Okay, we're going to have to take one thing at a time and kind of tweak our graph as we go to make it work. So the first condition, the limit as x approaches 0 of f of x equals 1. Okay, so that means from both ways, I'm coming in, because it's a two-sided limit, from both sides, when my x is 0, my y is approaching 1. If you look, let's just jump down below that real quick. It says f of 0 equals negative 1. What does that mean? That's a point. When x is 0, it's negative 1. Now, if this is a function, can both of those be closed? So what kind of circle does this need to be up here? Open. So you see, I'm already tweaking my graph. You have to adjust to make it true as you go. Okay, so I don't really know much. It could be coming in, it could be doing something like this. It could be a horizontal line there. I don't really know. Let's read more conditions and see. The limit as x approaches 3, so I'm going into 3 from the left, so coming in from this direction, is negative 2. Okay, does it tell me anywhere what f of negative 2 equals? Or what f of 3 equals? Yes. So what kind of circle should I put down here? This has to be open. And then I'm just going to kind of connect those somehow. When x is 3, if you look right below this, f of 3 is equal to 1. So when my x is 3, my y is 1. The last condition, as you approach 3 from the right, so from the positive side, it's going to positive 2. So can that be a closed circle? No, it's got to be open. And I didn't tell you anything about how that graph's coming in. So you could draw a horizontal line coming in, you could draw decreasing, increasing, whatever. Finishing off my graph, just going to kind of draw some line approaching this. You are just drawing a graph that fits the requirements, not the only possible graph. What I recommend once you get to the end is read all the conditions again and see if your graph works. This one had quite a few conditions with it. The limit as we approach 0 is 1, so as x is going to 0 from both sides, we are going to 1. As we approach our 3 from the left, it's going to negative 2. So we approach 3 from the right, it's going to positive 2. F of 0 is negative 1, f of 3 is positive 1. So just check at the end and adjust your graph as needed. Any questions? So that is the end of this section. I think I wanted to make one change on this possibly. I think no, I'll leave it. Okay, I'm gonna leave that. I think that's good. Okay, tomorrow, the majority of class time is going to be a work day. If things are going well and they're making progress, I might do a little bit of an introduction into 2.3 at the end of class tomorrow. I won't be assigning any homework from it, but I can't guarantee. It's just going to kind of depend on how class goes. I'd like to be able to do 5 or 10 minutes and just go over a few laws, but I don't know for sure. So please just check the video. If you're having problems with the homework, you can join the Google Meet and ask me there or send me an email. And I will go ahead and pass out the 2.3 notes just in case I start those tomorrow.